Hello students, I'm coming to you with another video on similar figures. So we're going to talk about critical attributes of similar figures. Well, first of all, there are three things that has to happen when you have similar figures. The first thing is similar means very close to, somewhat the same, but not everything is the same. So the first thing they have to have is the same shape. You can't have a rectangle and a square and compare them because they're not the same figure. So they have to be the same shape. The second thing is they have to have corresponding angles. And what that means is that if I'm a square and all my angles are 90 degrees, then in the other square, all those angles have to be 90 degrees. If I'm a triangle and I have angles of 50, 60, and 70, then all those, the similar triangles should have degrees of 50, 60, and 70, and they should correspond to the same side. And then the last thing is proportional sides. So I know y'all are tired hearing that word proportional, because that's what we've been doing for the last 2 weeks is proportionalities, setting up proportion, percent proportion, unit rate proportions. So, but we're still in proportions. So, some examples of similar figures. I'm not going to write these down, but just make sure you listen. So, some examples of similar figures in the real world. Well, usually, when you're trying to go on a road trip, you usually use a map. And your map is very small because it's able to fit in front of you. But this map scales bigger because, of course, if I have a map of the state of Texas, that's not the true size of the state of Texas. The state of Texas is miles and miles long, but my map might only be inches long. So that's a way that we scale something larger, same shape, they're just different figures, different size figures. Or another example is architectures. When they build buildings, before they begin to build a building, they have to plan the building, and they build little sculptures, little life-size sculptures of these buildings. And when they build these life-size sculptures, they then turn those little models into large models. So architectures, when they plan for buildings and such, they use them in a small form, or they build them in a small form, and then they make them on a larger scale, build them on a larger scale. So those are some examples, and maybe you can come up with your own. I would like to see 2 of your own examples if you have them. So next, similar figures problems can be solved using a proportion. You guessed it, because that's what we've been doing, and we're going to continue to use proportions to solve them. So I'm going to give you an example using proportions. So if you remember, this problem was number 1 on your short cycle assessment. It had 2 parallelograms. They were slanted, and one had 7 inches or 7 units and a question mark, and then this side had 10 and 8. And so when having similar figures, we check off, first off, are they the same shape? And I know that my drawing is just a little off, but they are the same shape. So that's a check. The next thing is, do they have corresponding angles? Well, what that means is that if I was to say that this was, let's say, 60 degrees, then that means that this angle looks exactly like that angle, and it should be also 60 degrees. So angles should be the same. This angle should equal this angle. So that's what corresponding means. Their angles should be the same measurement. Now the third rule means that sides should be proportional. So this is the rule that we're going to check. And what I can do is set them up in a proportion. So I'm going to highlight sides that are proportional. This side is the same as this side, the 10 and the 7. And then I have the 8. That is the same as the question mark. So I'm missing a side. So now I'm going to set it up just like that. I'm going to do my green here. And I'm going to do my pink here. Excuse me. Alright, so let's look at those numbers. And then also, with green and pink, I also have to set the shape up. So let's say the big shape goes here and the small shape goes here, because we got to make sure that everything matches. So I'm going to do 10 because that's my green side and that's on the big shape, and then green to the 7 side on the small shape. So big to small, but they're both the corresponding sides and they're both green because I highlighted them green. Then I have the pink side. Big shape is 8, small shape is a question mark, but I'm going to put X for a variable. And from here we know how to solve that. The X of the variable is on the bottom, so we flip to solve it on top. So we have 7 over 10 equals X over 8. I'm going to multiply by 8 on both sides. And I want to cancel 8 because I need to get the variable by itself. I need to isolate it. I'm going to put a 1 underneath 8 because I need to multiply my fractions across, and 8 was a whole number. And to turn it into a fraction, you have to put a 1 underneath. 8 times 7 is 56, I think. I know sometimes I can't multiply. And then 10 times 1 is 10. So from here I divide 10 into 56 5 times. I add a decimal and a 0 because we do not do remainders. 10 into 60 is 6 times. So my answer is X is 5.6. So my missing side is 5.6. Awesome. We're going to do more practice later on in the week. So if you don't get it now, it's okay. We're going to do practice. Bye-bye.